Excellent. OK, so I want to first, before I talk a little bit about the Vault infrastructure, I want to talk to you a little bit about the Apptio infrastructure. The reason I want to do this is because when you make a decision to deploy something at Apptio, you can't just decide willy-nilly to throw Vault into production. And the reason is because we operate at a reasonable scale. Obviously, we're not AWS or Google Cloud, but we're running around 6,000 VMs. We have what we would consider data centers in 15 global regions, whether that is a physical data center or an AWS VPC, and hundreds of MySQL databases. Our raw storage footprint as of this morning was about 3.5 terabytes. And we've got about 178 terabytes of memory and 170,000 CPU cores. So when you make a decision to install something like Console or Vault into that kind of environment, you can't just do yum install or download the Go binary and just hope for the best. You really have to think about the kind of things that you're going to do. We have, I think it's 500 to 600 employees, most of which are in the engineering department. So we need to think about these things a little bit. So the actual problem that we were trying to solve was, how are we going to allow people to get access to these hundreds of MySQL databases and do it in a way where we know who logged in where? If you think about some of the ways that you might access databases at the moment in your current role, you might pass around the root password. I hope you don't, but you might. How do you know which person used that root password at which time? And if a new person starts, how do you share that with them? How are you going to rotate that root password and then share it out again in a safe manner? I watched a talk by Liz Rice yesterday who said the longer that a secret is valid, the more chance it has of being compromised. And this was very much on our agenda. If you're not using the root password, something that I've seen in previous companies is that you might just go and look at the application configuration file and see what the username and password for that database is. If you're guilty of that, you have the same problem. You're thinking about how you're going to share the password. If you can log in and look at it, anybody else with the same permissions can look at that password. You really need to think about what the implications would be if an attacker got onto one of your machines and could see that password, especially when you're in the industry like we are, where we're taking care of companies' serious financial data. So we looked at Vault. And as you may or may not know, if you use Vault, it provides audit logging. It will tell me who requested a credential. It has database support, and we use MySQL, and it's already built in, which is really, really useful. It can be made highly available if you configure it in a certain way. And it provides us with a secure way to store credentials. This seemed like a perfect opportunity for us to try and find something, a use case to use Vault. If you're currently looking at a situation where you would like to use Vault and you're not sure why, human user access to databases is a perfect opportunity. But we needed to figure some things out. As I said, we've got 15 locations. How are we going to deploy that many Vault instances? How are we going to connect all these hundreds of databases to them? How are we going to do all the operational stuff, highly available, same backups, and make it safer? The thought process that we were thinking of here is, if you make this harder than looking at the configuration file for the database, people will not use it. If you give an operator the ability to log in and look at the configuration file, they're not going to use a tool that you provide for them. So we had to make it even easier than that. So we went on a journey. And the first step was to deploy Vault. We'd already deployed Console, and we were using it in all of our data centers, and we spread it across racks in the data center, so we don't lose quorum when we lose a whole rack, which happens. We spread it across availability zones in AWS where it's available, and we connect all these things up using WAN federation. In terms of actually how we deploy them, we use Puppet for configuration management. We already use Puppet to deploy Console. So if you want to use Puppet, or I'm sure there's Salt configuration, Ansible configuration, Chef configuration, to download and install Vault, we simply use this Puppet module that's there on the bottom left and deployed it in that way. What Puppet also provides is, if you're not familiar with Puppet, Puppet uses TLS to do authentication between the agent and the master. So we use that quite heavily to provide TLS in all of our data centers, because every VM already has a TLS certificate that's signed by an authority that we trust, which is the Puppet master. So we use TLS for Vault, which is provided by Puppet. And then the second step was we needed to initialize it. And at this point, you kind of think, OK, so I've got a lot of Vault instances around, and we want to make sure that we can initialize it in a safe manner. And we looked at all of the different options. When you initialize Vault, the default Vault init command will create a plain text unseal key that you then need to distribute to other people. That felt really unsafe to us, because then you have to find a secure way to distribute that key, and anybody with with all of those keys or a quorum of those keys can then get into your Vault instance. We were already using GPG for Puppet and for a variety of other things to check in secrets into Git. So we looked at the GPG configuration that's available in Vault, and we thought that was perfect. What that does is it creates an unseal key, which is encrypted by each user's public key, and only their private key can then read it back. It also has keybase support. If you're using keybase at all, I would highly recommend using it. And then we use the API to initialize all these vaults. You only need to send it to one. You only need to send it once to each cluster, and then you provide 9 GPG keys from different users in different teams in different departments in different regions, and then we specify that we need 3 users to unseal every vault. Okay, so the vault is initialized, and we've got it deployed in 15 data centers, and now we're like, okay, now I've got to unseal every single one of these things. And that seemed really daunting to me. We tried to do this manually, and I'll show you in a minute. Doing it manually involves echoing the key and then base64 decrypting it and then piping it to GPG, and people are like, I don't know if my GPG key is correct. Every time I send an unseal command, it's not working. What's happening? We were trying to do it manually, and it was just painful. And we got to the stage where we were waking people up in the middle of the night and saying, can you get on the call and unseal the vault, please? And people don't generally tend to like that too much. So what is the middle ground? You can automate this thing. You can't exactly leave the unseal keys and plain text on your file system. That kind of defeats the point. Unsealing Vault automatically is difficult, but I think I found a middle ground. I wrote a tool called Unseal. It's my first Golang binary, so if you read the code, please help me make it better. But what you do is you add all of the Vault servers to a configuration file, and then you add your encrypted unseal key, and what it will do is automate the process of piping that and base64 decrypting it and then sending it to the Vault. It will unseal all the vaults, and it runs each one of those unseal commands in a Go routine. I can unseal every single vault. I'm not going to close them all down because that would cause a problem, but I can unseal all the vaults, about 75 of them, in around 15 seconds. And I'd like to give you a quick demo. So I've provisioned some infrastructure in DigitalOcean. Let me just quickly show you what I've got here. I have multiple nodes. As you can see, I've got 3 console servers that are running Vault, and I've got 3 Vault servers that are also there. And we're in a pretty bad spot here because only one of the vaults is currently active, and all of them are sealed. Maybe we offline migrated the VM, or maybe we upgraded Vault to a new version, and I now need to unseal them. So I have a configuration file. As you can see here, I set the CA path at the top, and I'm using the Puppet certificates. I have a GPG flag that says I'm using GPG. If you're not using GPG, you can put your plain text keys in there, but if your laptop gets compromised, somebody's going to have them. And then I just specify an array of hosts, each of the console servers and each of the Vault servers. I specify the port, and then the encrypted unseal key. This is what I would usually have to do to get my unseal key. So I would echo the actual base64 encrypted string, then decrypt it, and then pipe it to GPG, and that's my actual unseal key. However, if I had to do that multiple times, even in a loop, I could get it wrong and all that kind of stuff. So I have this command unseal. I run status, and it will tell me that 5 of them are sealed. And if I run unseal, because I have GPG agent running, which is keeping my key, usually it would prompt me, but I didn't want to risk it this time, and I've unsealed all those vaults immediately. What this means is that any user that comes online in the morning, what's become a little bit of a habit to us, rather than reading back Slack to figure out if somebody live migrated a Vault server in one of the data centers or upgraded something, what has come a bit of a habit for me, at least, is I now run unseal status to see if there's any of the Vault servers need unsealing, and if they do, then I just run unseal. Okay, so we did the demo. Oh, what's happened here? There we go. And now we need to configure Vault. We need to add things like authentication policies. We need to add users. We need to add LDAP configuration, all that kind of stuff. When we started doing this, there wasn't a lot of good options around. I found a tool online called VaultCTL, written by the UK Home Office, which was really, really useful, and that's the path we went down. Seth wrote a fantastic blog post about how to do this in a codified manner. And then recently, Terraform now has a Vault provider, which makes this much, much easier. But I'm going to show you a little bit about VaultCTL in a second. But basically what you can do is define your Vault configuration in YAML files and then run the Vault CTL tool, and it syncs that configuration with each Vault in each data center. This makes it much, much easier. It's like configuration management for Vault. Let me stress, Terraform is a much better way of doing this. But at the time when we needed to do this, we didn't really have much better options. So after that, we have all these MySQL databases. We've enabled authentication. We've added a bunch of policies. We've added a bunch of auditing. And we've enabled the MySQL backend. Now I've got like 600 databases that I've got to add. We cheated a little bit here because we use a tool to provision VMs internally called self-serve. And when we create a new MySQL VM, basically what happens is Puppet runs and it installs MySQL. It adds a Vault user with the relevant grants, and then it adds the roles to each database config. So we have a read-only role, which allows developers to go in and do select statements to the heart's content, or you have a full role, which allows them to drop databases to the heart's content. And what happens then is self-serve makes an API call to the Vault in that region and adds it under a mount point. We mount the databases under the path MySQL because that's the old backend in the old version of Vault, and they thankfully deprecated it. Thanks, HashiCorp. And then we add it under the host name, so we can add multiple databases to into each Vault in each region. What next? So now all my databases are enabled, and they're all in Vault. How do I make it easier for each operator, as we'll call them, to log into those databases? We use LDAP. We use Active Directory LDAP. So we obviously have a bunch of role-based access groups, and what we do is we map each developer or each operations person to a role-based access group and then configure LDAP from there. However, once this is done, you've given a bunch of people access to Vault because you've mapped the group to the policy, but people were starting to get really, really frustrated downloading the Vault binary and then adding -method equals LDAP, like they forget to do that, and then they'd add username equals Briggs, and they forget to do that, and then they're like, okay, what's the path again? I forgot what it is. How do I get my credentials again? And you could document this until the cows come home, but if it's 3 o'clock in the morning and you just want to log into a database to fix a problem, you're probably not going to read that much documentation. So this became tedious for a variety of reasons, so I busted out my terrible Golang skills again and wrote another tool called BreakGlass. This is now open source. It's under the Apptio GitHub repository. And basically what this does is it automates this process away for you. It's kind of inspired by the Vault SSH command, if you've ever used it, which will automatically generate your credentials and log you into a box. It currently supports MySQL, SSH access, and also Docker access. I have plans to add IAM support and any other backend that seems reasonable that we use. And I will happily, again, accept pull requests. This is not good code. Please let me stress that as much as possible. So let me show you a quick demo. So I have the BreakGlass tool installed. Again, because it's a Golang binary, it's just completely available, and you can see here that you have a bunch of available commands. This also has a configuration file. You can use the user path. You can use the user path authentication method or the LDAP authentication method. No other authentication methods are supporting. So if you use GitHub, it's not supported yet because it expects you to provide a username and password. And because I'm logged in as root, I've specified my username Briggs because I'm doing it because I'm on DigitalOcean and nobody cares. And then I've specified the local Vault in the data center, so vault.service.console. So here you can see I've got a MySQL instance, and I want to break glass of MySQL on the host mysql-0-.briggs.lan. If I run this, it will prompt me for my username and password. This would probably be my LDAP password, but in this case it's not. And it's creating me some credentials. I can then go use those. However, if I'm lazy, which because I'm a system administrator I am, I can provide an exec, and it will log me right into the box. This is really, really helpful when you're trying to log into a database in the early hours of the morning. Let me assure you, because I've used it many, many times. If I look at the audit logs, you can see there's a bunch of information here about who requested the password, when, and why. So you can see here the display name, username L Briggs with these policies requested a bunch of information. This is instantly better than passing around the root password. If you get some kind of breach and you get the root password and you have no idea who's responsible for this, I personally believe this is much better, and I think it's perfect for what Vault was designed for. So I've absolutely motored through this, so I'm usually on final thoughts. What I would like to do real quickly is just show you the Vault CTL configuration. So here you can see there's a bunch, I've specified a file with the authentication types. In this case, I've got user pass. I have a bunch of policies, and in this particular case, I've called the policy operations because I'm in charge of Vault. I have a bunch of policies that I probably shouldn't have access to, like sudo to sys. And then users. I've created myself a user with a super secure password of password, and then assigned myself some policies. And to run that, all I need to do is run the vaultctl command from this directory. You can see I'm specifying vault.service.console on port 8200. That's my root token. I'm going to tear this down so you can't use it. And then I'm going to sync this directory. And then it's updated all of the configuration for Vault for me. Obviously, you probably wouldn't use the root token if you're using vaultctl usually. You would probably use it locally from your laptop or something like that. But in this case, because I'm just doing a demonstration, I didn't want to have to deal with all the policy stuff. And you can see here, it's added the backend, which was already created. The policies were already there. The users were already there. And I don't have any backends or secrets to sync, so it hasn't done any of that stuff. So that was the journey. And at this stage, we have a bunch of operators that are able to log into databases really, really easily. And we have distributed this over multiple data centers, and we now have a vault setup which we feel comfortable with. The nice thing about this, in terms of the first thing that you're doing with it, is at the end of the day, if you somehow manage to screw up Vault in some way, you're not losing access to a bunch of secrets. All you're doing is you're losing access for humans to log into databases. The way that I was thinking about this was, we want to become comfortable running Vault in production before we start throwing our, TLS certificates into there and our root password and all that kind of stuff. And we ran like this for quite a period of time before we felt comfortable adding other things into Vault. So there's some of the final thoughts that we came up with after we went through this journey. Auditing is an interesting thing. You can see there, that's an example audit log. We ship all of our logs off to Splunk, and as you can see at the bottom there, it's kind of small, but the data is obfuscated, so the actual username and password that gets generated by Vault is not output into the logs. What this means is that when you want to actually find the person who logs into a database, is you need to provide the string either from the username or the password, and Vault will tell you which audit log entry it is from. And you use the sys audit hash endpoint. You can do this manually, but I am currently working on a tool that makes this much, much easier, so watch this space. The second thing that we thought about is, okay, so we have this Vault endpoint, and we don't have our ACLs turned on. This is how Vault looks in the key value store. No, iCloud, go away. And we've initialized Vault under a path of the data center name in DigitalOcean. And you can see here, if I have access to port 8500 on console, I can delete everything immediately with no recourse. So you have to turn on ACLs if you're going to do this, and if you're going to use console as your Vault backend. There is a great write-up here about somebody doing a bug bounty, and they're using console, and they don't have ACLs turned on. There's other things that you need to consider here, like by default, up until recently, console exec was turned on, or you could just add a new health check endpoint, and people could just register health check that ran scripts. So please, if you take nothing away from this presentation, please turn ACLs on. If you're storing your secrets in console, don't give them access to this thing so they can delete all of them. And you have to do, it's a little bit of an investment, but if you haven't deployed console up until now, or you're using console, I would highly recommend that you think about it. Backups. So once we've deployed all these vaults, we need to think about the story of how do we restore all this stuff to another data center during a disaster recovery event. As you can see earlier, we initialize Vault under a prefix. By default, it's Vault, but we add the data center underneath that as well. We never replicate secrets between data centers. We have things like customers who don't want their information being replicated out of region. We have customers who don't want their information to come into the United States, for example. And so for that reason, we made the decision not to replicate things into other regions. What that means is then you need to think about how you're going to deal with backups. Console now has a snapshot command. It didn't originally, but it does now, which is really, really useful. We take a snapshot once an hour, and then we copy them to another data center, which is reasonable for that region. So if it's in Europe, it goes to another European data center, and if it's in the US, it goes to another US data center. And then we test the restores regularly. All you have to do is start the Vault binary on a different port, connect it to an existing console. So you already have console in that data center, but you can initialize it under a new prefix. So for example here, if I had a DigitalOcean region of the San Francisco, I could initialize it under a different prefix, and I've got two vaults connected to one console. We do that via Ansible, so it starts Vault on a new port, it updates the configuration, starts it up, and then we get everybody to run Unseal with the new configuration file, and then you can verify the integrity of those secrets, and then you can shut it down and you can come back to it later. Having an Ansible playbook to do that means that your disaster recovery story looks a lot better when you're doing those wonderful DR tests that you're supposed to be doing. So final things. We learned a bunch of lessons here. I learned a bunch of lessons here. But I think the first thing that I would take away from this is, if you want to use Vault, don't try and consider it as the be-all and end-all of your secret storage. Pick one thing and go and vault it. In my case, it was human user access to databases. But if you have a specific thing that you think could be much, much safer, I would recommend just picking one thing and iterating. Think about how you're going to do configuration, backups, and unsealing stuff. Hopefully the tools that I've written will help you, but you do need to think about how you're going to unseal the vault in the time of emergency, especially if you have a distributed team and you have 3 users who need to unseal it. Console has a bunch of backends. Vault has a bunch of backends. If you're already using Console, I would recommend using that as your backend because it gives you HA immediately. If you're in Amazon and you want to use one of the Amazon backends, then of course that makes sense. But Console gives you service discovery and all that kind of stuff. And then any kind of automated secret management has these kind of trade-offs. As long as you're aware of them and you can abstract and make them safer where possible, I think it makes more sense to automate them as much as possible. You will always have the secret zero problem. You will always have that kind of, how are we going to make this safe and distribute this kind of stuff without potentially jeopardizing, jeopardizing the situation. At the end of the day, as an operator, you are the biggest attack vector. I know I hear it gets said all the time, I'm not a security engineer, but at the end of the day, I'm fairly sure if there's any InfoSec people in here, they're probably going to sprinkle USB sticks in the car park before they start thinking about how they're going to get through your firewall. So think about that. Unseal is useful, but it's only as useful as how safe you keep your personal laptop. And then the final thing that I think I'd like to say as a takeaway, engineers, at least from what I've seen, I personally think engineers love Vault for its HTTP API. I don't believe there's anything out there that does secret management in the same way that Vault does. I've seen hardware KMSs, I've seen a bunch of other open source tools, but having a HTTP API for your secrets that you can feel comfortable and secure with is a really compelling story. You might be in Amazon and using the Amazon KMS, and that's fantastic too. But if you're in the physical data center game like we are, you need to come up with other solutions. Unfortunately, that's all I have. I have about 11 minutes left, so apparently I talked too fast. It was fantastic to share this with everybody, and I would like to thank Nick for giving me the opportunity to do this.